Hi folks, so this chapter will be about primitive constructs and concepts that are common to almost all, if not all, programming languages. So we'll need some of these to be able to write sample programs. And the first lesson is about variables. So to explain what are the variables, let's remember that a program is a set of instructions that, when executed by a computer, performs a certain task. And to perform a meaningful task, most likely we'll need to manipulate some inputs, some outputs, and store some temporary intermediate state, which means the task will have to work with data. And to be able to access, which is read or write data, we need to work with variables. So a variable is basically, in the very simplest definition, it's a named piece of data. If we make this definition a little better, it would be a name or an alias for a block of memory that stores data or values of some type. So to make sure we understand what we are talking about here, let's think about two problems, very simple problems. One is adding up two numbers when we write under each other and start adding up from the rightmost bit, basically the least significant bit. And then if the value is if the sum of these two digits is greater than the base of the numeral system we're using. So let's say in the standard base 10 system, we add up, let's say we have 17 plus 19. So if we add 7 plus 9, it's 16. So we cannot write 16 under it. We have to have only one digit. So we need to remember the 1 to carry over to the next position. So that's one example where we need to store this 1 in some place. So we'll have a variable to store this 1 and carry over, and then remember to add up it on the next position. Another example is, let's say we have to write a program to count the number of orange juices in a fridge, right? So we'll start, let's say the fridge is full of juice boxes and of different flavors, and we want to count only the orange juices. So we'll start counting, basically looking through all the rows and columns, and whenever we see an orange box, we just add up our temporary counter by 1. So that's another case where we need to store some information, and then at the end we'll have the number of orange juices. So these are just two very simple examples to give you an idea of how would program store something, why would we need to store something. So as I said, a variable is a name or an alias for a block of memory where we store data. So if you want to read that data, you just access it with that variable using that variable. And when you want to write, you again access it with the same variable. So the way we create variables depends, the actual syntax depends on a programming language, but usually there is some keyword and then the name of the variable, and that's it. That way we can create a variable. So for instance, I have here, let's say we can say a equals 1. So when we say equals 1, it's actually not, we are not saying the value of a is 1. We are saying assign 1 to the variable a. So assignment is one of the operators. We'll get to operators in a later video. But for now, most of the languages have these two ways of creating variables. One is declaring a variable, and the second one is defining. And declaring is when you say, I want to have this variable because my program will use it later. And defining is when you say, I want this variable with this value. So you declare and assign a value to it at the same time. That's called the definition. And different languages have different requirements. So some languages don't even need, some languages require you to declare before you can use it. In some languages you can just create at the point of using it. So we don't need all the details, but I have here some examples of declarations and definitions. You can see that different languages have different keywords, as I said, for creating a variable. There is let, set, var, and then most of the languages support the way where you just specify the data type, and we'll get to types in the next video, and then the name of the variable. So so far we talked of variables as only numbers, but as I said, it's a piece of data, so it doesn't have to be a number. It can be a character, it can be some complex object. Again, we'll get to objects in future videos, but just assume anything you can store in memory. You can have a variable that is an alias for that piece of memory, and you can access that piece of the value in that memory using that variable. So for the types we'll get in the next video, but as I said, we have definitions and declarations of variables and also names. So the names, there are different conventions for how to name the variables. So conventions is basically saying how to name your variable so that other people reading your code will understand. There might be some special naming conventions that help with knowing what you store, what type of data, or what really this variable is for. And then there are also requirements, which means if you don't follow this in naming your variables, your code will not compile, so you won't be able to run your program. So most of the languages require that the names of the variables only have alphanumeric characters, which is all the letters from the alphabet and the digits from 0 to 9, and also you can use underscore. Some languages will of course allow more characters, but again, this is just a detail we don't have to know at this point, but just for your information. So that's about naming, and here I have another sample program which says which basically calculates the sum of all integers from 1 to given integer. And from now on, let's assume we have these two special keywords, input and output. And when we write input, it means the user of the program, whoever executes that program, will be prompted to input something. And at this point, when we say var a equals input, let's say we expect a number in the input, so someone will type it, and then a will get assigned the value, the typed in value. So then the next line is the formula for calculating the sum from 1 to n. And if we don't know this formula, we'll write the program without knowing the formula. But in a future video, we'll keep using this example. It's a good one. And then, so see, we have a sum, which is a temporary variable. And then at the end, we just output that sum. And let's agree that output is another keyword we'll keep using to keep our samples language agnostic. So we'll assume output is whatever you provide in the parentheses, it will just print it on the screen. So we'll take input, we'll calculate the sum, and then print on the screen. So in next video, we'll cover what types of data, what types of values we can store in variables, and what the types really define, what they mean if the variable is of type A and is of type B. So in next video, we'll cover those. Thank you. See you in the next one.